Oh, and she's on the floor. Yeah, I think it is. It's super long. That was
Okay. Ooh, somebody needs to turn the light. Objectives for chapter 13. And so we're going to be looking at exercise and cardiovascular disease, and then exercise prescriptions like training program periodizations, things we can do to improve aerobic fitness and capacity. Okay. So it's a really fun chapter. I think you'll like this one a lot. The prevalence of cardiovascular disease, it's gone down some. In the 70s, it was around 50% of death in the US was from cardiovascular disease, and now it's somewhere around or in 2004 it was somewhere around 36%, so it's come down a little bit. Part of that, less people smoke than they used to, so that's part of the reason, is that smoking has dropped off, not gone away unfortunately, but it has dropped off. And so somewhere around 71 million people are affected, and about 1 million of those will die from some form of cardiovascular disease. We've got amazingly improved medical treatments now for cardiovascular disease. You can have a stent put in, you can have a bypass done, they can do an angioplasty where they put a little balloon. So it's really pretty amazing what they can do, and we've got better understanding of drug regimes for long-term treatment. So a lot more people live long-term with cardiovascular disease than we used to see. So, can we see that? Okay. We need to turn the light off.
Yeah, you probably turn the light off would be a better idea.
So, when we're looking at this chapter, when we're talking about a fitness benefit, then we're looking at a physiological adaptation that would increase performance in a particular sport or activity, an event, right? So, vertical jump may get better with this adaptation, or strength, or lactate threshold, right? And then if we're looking at a health benefit, we're looking at a physiological adaptation that reduces the risk of disease. So when we're speaking to people, when we're talking to an individual, or to, particularly if you're looking at personal training, you really want to make sure that you use the right terminology. Are you looking at a fitness benefit or a health benefit? Because it's kind of like that using, if I say exercise, then that immediately translates into I have to go to the gym, right? If I say physical activity, then we've got this much broader opportunity psychologically for physical activity. So use the right terminology depending upon the person that you're communicating with. All right, so we're going to look first at exercise and cardiovascular disease. All right, this diagram is in your book, and it's a really nice way of showing what's going on. Here's the right coronary artery. Remember, the coronary arteries wrap around the outside of the heart to supply the heart with oxygen and nutrients. Okay? So it's not going to take what it needs from the blood that's inside. It needs all this network of arteries wrapped around. So the two major ones, the right and left coronary artery, are quite large, and then they branch out into these little fingers that sort of wrap around. Okay. So with coronary artery disease, we get a blockage. So on this picture, the blockage is just here, right? And then that means that due to the blockage, any of the tissue that's being supplied by the vessel the other side of the blockage isn't going to get enough, if any, oxygen and nutrition, right? Depending on how bad the blockage is. Okay. So we can get ischemia, which means that there's a partial blockage. So this blockage here wouldn't occlude the entire artery. And ischemia is an interesting one when you're in movement, because often people who are sedentary have ischemia without knowing about it. Because when the symptoms occur is when you stress the heart, and there's not enough oxygen and glucose getting to the tissue. So quite often, it becomes noticeable that there's a problem during an exercise or physical activity session. So it's very common for people in the gym or your personal training clients to say, oh, I have no problems, and then when you start exercising them and stressing the heart, all of a sudden they're starting to get chest pains that aren't there regularly. All right, that's why it's really important that you get those doctor permissions and sign-offs ahead of time, because if you're exercising someone and they have this problem, then now the onus is on you. Why were you exercising someone that has a problem? But you wouldn't know it was there. Okay. So they're gonna exhibit severe chest pain, so they might clutch at their chest or bend over. All right. Watch for body language, because that's really important. Sometimes people don't like to admit that they don't feel good, right? So they may try to work through it. So you've got to be really pretty adept at picking out body language that's implying that they're having a problem, okay? Then the next thing that can happen after the ischemia is myocardial infarction. So that's the fancy term for a heart attack. And that occurs when you've got a complete blockage here. So now that tissue, the other side of the blockage, isn't getting any of the things that it needs in order to contract and function properly. The blockage is going to be occurring partly because of atherosclerosis, and we'll come back and look at plaque in a minute. So the artery gets narrower and narrower and narrower inside because there's this plaque buildup that's solid on the inside of the artery wall. And plaque is not flexible like the wall of the artery. Right? The muscle wall of the artery is pretty stretchy and bendable. Plaque isn't. Plaque's hard. So we not only get a narrowing, you can also see thickening and a loss of elasticity. So the artery can't give anymore. If this plaque buildup is occurring very quickly in an individual, then you could start seeing ischemia and even large enough blockage to cause a heart attack in an individual's 20s or 30s. Right? Or plaque buildup can be very slow, and you may live into your 80s and die of old age and actually have had some plaque buildup. So there's a lot of genetics involved. What's your genetic makeup? What's the propensity you have to develop plaque? A lot of it is lifestyle, right? So even if genetically everybody in your family had heart issues, doesn't mean that you have to necessarily have heart issues. You may be able to control what's happening through your lifestyle. And a lot of people have no genetic background at all for heart disease, and yet develop heart disease because of the lifestyle choices that they make. We're seeing forms of atherosclerosis in very young children. So somewhere around 5 or 6, they're starting to see some fatty streaks. By 10 and 12, it's getting pretty bad. So we're not developing lifestyle habits that are keeping us healthy at all. So if we're seeing it that young, then by the time they're 20, plaque buildup is going to be bad enough to start causing some severe health issues. So inside the artery then, usually the initial thing that happens is some kind of damage to the inside of the wall. So that could be because you've got a high level of low density lipoproteins and they're scraping along the inside of the wall. Right? There's some research that I read that said if you drink a lot of fizzy drinks and you have a lot of sugar in the system, that the insulin response with the sugar and things can damage the inside of the wall. Once there's any kind of damage, then that sets off a progression that ends up with this big lump of plaque attached to the inside of the wall. And the plaque can be quite thick. It can have a thick shell, so it's all these unpleasant cells covered by a shell. The shell can be quite thick, and the plaque will stay in place, and that artery will be narrow and not function very well. Or the plaque wall can be quite thin, and then it's at risk of rupturing, and now all this stuff floods out outside of the artery and causes a blood clot. And you get a thrombus. And then the blood clot could jam there, or it could travel around and get stuck somewhere else and cause a stroke, for example. All right? Or it could travel from a very small artery, and it might travel and end up in a bigger artery, and therefore the damage would be more extreme. So, right? Does that make sense? So we're not looking at a very pretty picture when we're looking at this plaque buildup. Let me see. Risk factors for plaque buildup: age. Right? You see plaque even in healthy people when they're older. Right? It's just something that happens. There's some damage to the inside of the arteries as you get older. That just happens. And so most people are likely to exhibit some level of plaque if they live into their 80s. Just depends where it is, how bad it is, right, as to whether or not we see the symptoms. So older than 65, pretty much everybody's got some level of plaque around. And being male, sorry guys, you're at more risk than we are. And heredity, so your genetics. Controllable factors, so I can't do anything about it, right? I can't do anything about my age, I can't do anything about being male or female, I can't do anything about my genetics. So those are the things I should be aware of in my family health history, and then make hopefully wise choices with my lifestyle. The controllable factors, the lifestyle factors, are the primary concern, because they're the ones that, given the opportunity, I could change if I wanted to, right? So smoking, tobacco, big risk factor. Blood lipid profile. So if your, bless you, if your lipoproteins, if your cholesterol is too high, or you have the bad kind of cholesterol. Hypertension, so what's your blood pressure? Okay. Is it less than 120 over less than 80? Remember when we did blood pressure in lab, that we were looking at those numbers, right? So over time, can I keep my blood pressure within a healthy range? Obesity and overweight is a risk factor. Overweight isn't as big a risk factor as long as you're active. The bigger risk factor is being sedentary. Psychological stress, any kind of stress, is bad if it goes on for a long period of time. So chronic psychological stress, if I'm in a job that I really, really don't like, and I can't see a way out, so every day is stressful at work, then that can lead to a higher risk of disease. Diet and nutrition choices, developing type 2 diabetes puts you at higher risk. So, another form of cardiovascular disease are forms of stroke. Right? So, coronary artery disease is this blockage occurring in one of the coronary arteries at the heart. Strokes are the same idea, but they occur somewhere in the brain instead. So lack of blood supply because there's a clot or there's atherosclerosis. Wherever the blockage is, the brain tissue, the other side of the blockage, isn't getting enough oxygen and glucose. So where the blockage is dictates the type of symptoms you're going to see. Often the symptoms involve paralysis of some muscle group and therefore some change in functioning. Okay? And we have a couple of different types. The first one is called ischemic. So an ischemic stroke is when I get blockage of the vessel and cell death the other side of the blockage. Okay, so it could be, the blockage could be a thrombus, could be thrombosis, or it could be what they call an embolism, where you threw a blood clot somewhere else and it traveled to the brain. So about 83% of strokes are this version, so it's the most common form. And then the other version is a hemorrhagic stroke, and in a hemorrhagic stroke you actually see rupture of the blood vessel rather than just a blockage in the blood vessel. It could be cerebral hemorrhage, so an artery that's running through the brain tissue, or it can be subarachnoid hemorrhage, so one of the arteries that runs across the surface of the brain ruptures and then the fluid is released into the very tiny little space between your brain and your skull, and that puts pressure on the brain. Hypertension, atherosclerotic damage, so if I've got plaque buildup, it can occur in these types of arteries just as much as it can in the coronary arteries. It can occur in any of your peripheral arteries, right? It's not fussy. It's just it's obviously gonna be more dangerous if it's occurring in the brain or in the heart. Hypertension can cause an aneurysm. So if I was able to look very closely at the walls of the arteries, you sometimes see a wall that is a little bit thin, or it's starting to bow out. It's losing the musculature is broken down for some reason, right? And then when you stress that, it ruptures. So that can be genetic, right? People die of strokes in their sleep who were otherwise perfectly healthy because there was a weak artery in the brain. How would you know? I mean, there's no way of knowing. Right? Or it can be due to hypertension and the amount of force that's being applied to the wall of the artery. Again, the symptoms, if the person doesn't die, the symptoms are going to depend upon whereabouts it occurs, right? And what's the extent of the damage in the tissue the other side of the hemorrhage. Then, so we've got coronary artery disease, we've got stroke. A third type of cardiovascular disease is heart failure. And in heart failure, the ventricles can't contract properly, and so cardiac output drops down. So if the left ventricle can't squeeze really hard and get all that blood out around the body, remember cardiac output at rest around 5 liters per minute. So that's a lot of work the heart has to do. Okay, I have to keep this shut now. I'm under orders. But the good thing is it's going to make this part of the classroom empty and everybody's going to move more because no one's going to want to be responsible for opening the door all the time. So the heart has to work harder because cardiac output is too low to supply the oxygen and nutrients that the muscles need to work, right? So with heart failure, you see an increase in heart rate, and a heart attack can produce acute heart failure, right? So if I've got lack of nutrition through an artery that's supplying a ventricle, then we can see some acute heart failure. That could be due to drug abuse, some kind of substance abuse, and it could be due to a blockage. Right? So the ventricles aren't able to do their job properly. Chronic heart failure, so long-term low cardiac output, is usually due to hypertension. You could have several minor heart attacks that you don't even know you have. So, people have little mini heart attacks while they're asleep. They wake up, everything's fine, they go about their daily life, they have no idea that they had the heart attack. So if you have several of those, then you can start to see chronic heart failure. The other term for chronic heart failure is congestive heart failure. Right? Or it could be a viral infection. So there are certain viruses that attack the muscle of the heart. So that can result in heart failure. So if it's bad enough, then they may do a heart transplant. They're getting really good at heart transplants. So, that you would think a heart transplant would be absolutely the end of everything. But they're very, very successful now. So bypasses, very, very successful. Putting a stent in, they barely even put you asleep to put a stent in anymore. All right? You're in and out of the hospital in a very short amount of time. So they're getting very, very clever at managing these problems. It would be, in my view, a lot better if we didn't pick lifestyles that led to the problems in the first place. So if we can get people more physically active, if we can open up opportunities to be more physically active. So just quickly, we looked at hypertension in labs, so let's just review quickly. Chronic high blood pressure at rest. Now remember, one blood pressure measure doesn't make you hypertensive. You have to have a long-term picture over several months before they would clinically diagnose you as hypertensive, okay? Anything over 140 over 90, right? We have that pre-hypertensive little area where I'm at 120 to 139, right? And 80 to 89 for diastolic. Once we hit either 140 or 90, then we would be classified as hypertensive. That means the heart's having to work way, way harder to expel the blood through the valve out around the body. So we see big increases in resting heart rate, increased oxygen demand through the coronary arteries because the heart is having to work so hard, so it needs more oxygen to create the ATP to push the blood out against high blood pressure. Okay. And so that puts more strain on the arteries, and then plaque development is easier because of the damage, and so the big ugly picture goes on and on and on, right, once we start. So, more common in people who are obese and possibly overweight, particularly if they're sedentary, and the estimation is somewhere around 1 in 3 adults in America are hypertensive, which is a lot of people. Okay. Especially when you consider that mostly hypertension is lifestyle, not genetic. Okay. Not always, not completely for everybody, but mostly it's a lifestyle scenario. You can see pathological hypertrophy of the heart. So we said that that left ventricle, if we exercise really hard, we see increased left ventricular mass. The muscle gets thicker, right? It gets much stronger. That's a good thing because it's in response to exercise. You see similar adaptations in people who are hypertensive because the heart is having to work so hard, the adaptation occurs to try to deal with the additional work, but the work is not exercise, the work is just living, breathing. Okay. So in that case, the hypertrophy is pathological. Okay. So somewhere around 65, 70 million people in this country. It's a lot of people. That's just a reminder of the numbers that we saw in lab. Okay. If you are at stage 1, this can often be managed by an appropriate exercise program. If you are at stage 2, it is likely you will be told that you should not exercise. Until it's down here, because this is pretty dangerous. Let's see. Okay, blood lipid profiles then. Blood lipid profiles. So anytime you have blood work done, if you're having your annual physical, they're going to take some blood work and check your lipid profile, and the lipids are carried on proteins in the blood, so they move around the bloodstream. And what we want is not a lot of low-density lipoproteins. We want lots of high-density lipoproteins, so HDLs and LDLs is the phrase you usually hear. Okay. And now we have a new group, very low density lipoproteins, and they're really, really, really bad. Okay. So I want my LDLs to be less than 130 milligrams per deciliter. HDLs, I want more than 60 milligrams per deciliter. They'll also measure triglycerides. Remember, triglyceride is the storage form of fat. So we shouldn't have too much of it moving around in the bloodstream because most of it should be getting stored. And then when we need it for energy, we would break down the triglyceride and release what we need to make ATP at the muscle in Krebs cycle, right? So there shouldn't be a lot of triglycerides floating around in the bloodstream. And now what they're looking at is this total cholesterol. If I add my LDLs and HDLs, and what's the ratio of the total cholesterol with the high density, right? That seems to be the way the research and the literature is going as the best measure. What's the ratio of my total cholesterol to my HDLs? If my ratio is greater than 5, that is identified as a much greater risk of developing coronary artery disease. And if my ratio is less than 3.0, then I'm at low risk of developing coronary artery disease. Okay? When you put the LDLs together, the other way you see it is if they're not looking at that ratio, then what I want is a low measure for my LDL and a high measure for my HDL. So when you get your blood work done, you can start to pay attention, right? Don't sit back and wait for the doctor to tell you whether or not you're okay. Right? Doctors respond very well to people who take interest and know some of the things that they should be looking for in their results. Right? Otherwise, doctors tend to gloss over everything and just treat us like we're infantile. Yeah, go away, you're fine. Oh, wait, what's that number there? Explain that number to me. Right. I know my LDLs are supposed to be less than 130, and that says it's 135. Is that a problem? Then you'll start to get an intelligent conversation from the clinician and the doctor. Because they don't like to try and explain something that is a little bit complicated to someone that has no background. So if you use the right terminology and you've got some idea of what the numbers should be looking like, you'll be able to have a much more sensible conversation about your health risk given your results. Okay? Oh. It always works going in with your ex-phys textbook, always a good plan. You go, and they'll go, no, everything's okay. And you can open the book and go, wait, explain this. Always much better. Okay. So, again, we talked about this in lab. It's really, really important that you get medical clearance for anybody that you're likely to work with, all right? Unless you're a PE teacher, in which case the school is going to take the responsibility of having a health check on the children, right? Parents will have to have signed off that the child can be in PE. If there's any health risk, it will be on their file and you should be notified as the PE teacher. If you are not a PE teacher, if you're a coach or if you're a personal trainer or if you're at a recreation center that happens to have some aerobic equipment or weight equipment, then you need to make sure that you get medical clearance. That can be a letter from the doctor. It could be one of those forms that we looked at in Lab 1. Right? It could be the PARQ that you guys have to do to take part in physical activity within a class. Right? Any of those forms give you some support if anything goes wrong with the training program. I don't know that they completely exonerate you. Right? I suspect when you take sport law that what you'll be told is even if you have a form that's signed off, if something happened to that person, you could still have to go to court. But you're going to have a lot stronger argument if you get sued if you've got a validated piece of paper that said this person was okay. Right? You want to transfer the risk to the doctor. The PARQ on its own is not going to be enough. Get the doctor's sign off as well. So, even though we say you've got to have it for these situations, I would say have it for everybody. Because if you get sued, your house is gone. You will lose your house if you own one, right? Or if the bank owns one for you. Right? So make sure. If you're trying to treat hypertension, so if someone comes to you and the doctor has said you know, if you started to exercise and you ate better, we could probably bring your hypertension down without having to resort to medication. Then we want to be careful about what kind of exercise we start with, all right? If they're hypertensive, what happens when we lift weight? What happens to blood pressure when we lift weights? Skyrockets, right? Goes up through the roof. So, if someone comes to you with hypertension and their blood pressure is already high, don't use a weight training program. Right? Put them on an aerobic program where we do not see increases in diastolic blood pressure. Right? Put them on a gentle aerobic program, get them in better shape, get the blood pressure headed in the right direction, and then add the weight training and the resistance work. Let's see. Did we go through electrocardiogram? We went through electrocardiogram before, right? When we did the chapter 5 or 6. If you do a graded exercise test, they will put an ECG pad and attach electrodes. They can pick up cardiac arrhythmias, so if your QRS complex is really spiked on one contraction and then not spiked on the other, or there's a big long gap before the QRS, and so it isn't on a regular basis. The QRS represents the ventricles contracting. So if you go back to that heart failure idea, heart failure is when the ventricles are not doing their job properly. So there would be an indication in that QRS complex that the ventricles were not working correctly. So the people who can read ECGs well can get a lot of information from a stress test. All right, so we're going to look at then on Monday, we'll start looking at actual programming issues to improve aerobic, and we will probably do the fit Monday or Wednesday.